Okay, again, we're working on probability assignment 2 for Math 115. We're continuing on with question 16. A blood bank asserts that a person with type O blood and a negative Rh factor can donate blood to any person with any blood type. Their data show that 49% of people that have type O blood are 16%. I'm going to stop right there because we're going to say O equals 0.16 if I was turning that into a decimal. Of people, okay, so sorry. The data show that 49% of people have type O blood. Sorry, 49. So that's 0.49 for O equals 0.49. Now, it says then, and 16% of people have the Rh negative factor. So 0.16 for my Rh negative. And then 52% of people have type O or Rh negative factor. So O or Rh negative equal 0.52 for me. Now that's always going to be different for yours. So basically I wrote it out like that. O equals 0.49 for me, Rh negative equals 0.16, and O or Rh negative will equal 0.52. Okay, then the first part of the problem, find the probability that a person has type O blood and the Rh negative factor. Okay, so what do they want? They want O and the Rh negative. We don't have that, but we do have some other clues, right? So since we have this one here, let's see if we can plug in everything. O or Rh negative, right? We have that. And then we do the formula for that. Probability of O plus the probability of Rh negative minus the probability of O and Rh negative. Okay, so what do we have for here? We have 0.52 for mine. My O would be 0.49. My Rh negative would be 0.16. That's my probability. And then this, I don't know still, so I'm just going to bring it down just like that. Okay, so I can combine these two, which for me, when I add those together, 0.49 plus 0.16, I get 0.65 minus, I'm going to get rid of the p for now, just so we can kind of just see it as, now this is just one, just imagine as if this is just one letter, x, something like that. Okay, then I want to get this alone, so I'm going to do the opposite. Since this is a positive, we're going to do negative on both sides. That cancels that out. And if I went 0.52 minus 0.65, let's get that calculator. Right? I've got 0.52 for mine minus 0.65. I'm left with a negative 0.13. Negative 0.13. Okay, so let me zoom that out. Equals, this is gone, so now we're left with a O and Rh negative, the probability of that. Okay, so that's together. Okay, so this can't be a negative, O and Rh, and it's not alone. This is not alone yet. There's a 1, a negative 1 with this. So we have to get rid of that negative, and since it's a multiplication thing, we have to do division, right? So we're going to get rid of that negative here. And we've got a negative 0.13 divided by a negative 1 turns it into a positive 0.13, right? And that equals O and Rh negative. So that's what our answer is going to be. That's basically how we come out with that's how we find the O and RH, which is what we were looking for, right? The probability. Sorry, I should put a P. Probably the teacher would have a heart attack if you knew I didn't put a P. Okay, so probability of O and RH negative. Okay, so we got 0.13 minus 0.13. Your numbers are going to be different, but just follow the formula, grabbing each one, putting a mark for what you're doing. Okay, now it says find the probability that a person does not have both type O blood and the RH negative factor. Well, if you've got 13% of people that do have it, well, then what's the amount of people left that don't have it? So just think of it in percentage. We got 13% that do have it. Well, there's only you can only go up to 100%. So 100% minus 13% equals 87%. Or if you're doing it in the decimal form, just remember you can't go any more than 1. So 1 minus 0.13 is going to come out to 0.87. But I like to do it this way with the percentage, and I just think, okay, where's the decimal going to go? Move it 2 over. That's just the way my brain works, but you do it however you feel like. Okay. Then we've got the next one. Next one, we've got at a college, 72% of courses have final exams. Now, when I'm doing these problems, I don't know about you, I just start marking things, and it doesn't have any letters for me, so I used F for mine. And it was 72%, so I'm going to turn that into a decimal for the final exams. And 44% of courses require research papers. I'm going to use R for my research papers. So R, and it's 44% for me, so I'm going to put 0.44. And then suppose that 27% of courses have a research paper and a final exam. So 27 have both. So we know that F and R equals, for me, 27%. So find the probability that a course has a final exam or a research paper. Okay, we've got the probability of final exam or research paper. Again, we're going to get really good with these formulas. P, final exam, probability of the final exam. Oh, what am I doing? Plus the probability of the research minus the probability of F and R together. Okay, let's see what we do have. We don't have this, but we do have this. F, the final exam, probability of the final exam is 0.72, the R, 0.44. What goes in between? The plus sign. Minus, do we have this? Yes, we do. It's 0.27, the F and R, right? Final exam and research is 0.27. Let's put them all together, all three. Okay, 0.722 plus 0.44. Let's see here. 0.72 plus 0.44 minus 0.27. For me, that comes out to 0.89. So we know F or R equals 0.89. Okay, then I type that in, right? I've got that in there for my part A. Find the probability that a course has neither of these two requirements. Again, you have to minus it from 1 minus 0.89, and you're going to get 0.11. Or if you went 100% minus 89%, it's 11%. Move the decimal over 2 times, you got 0.11. Okay, simple. In a box of assorted cookies, we've got 34% contain chocolate cookies. I'm going to put a C for chocolate, and that would be 0.34. And then 15% contain nuts. I put an N for nuts. I got 15.15 for me. Then we've got 5% contain both chocolate and nuts. Again, it's the both. C and N equals 0.5, which if I turn that, I'm sorry, 0.05. 5% move 2 decimals over is 0.5, right? 5% move 2 decimals over, we got 0.05. Okay, turn it into a decimal. Okay, so that's what we've got so far. We've got the chocolate for me is 0.34, the nuts is 0.15, and the chocolate and nuts together we got 0.05. Okay, find the probability that a cookie contains chocolate or nuts. Okay, we got chocolate or nuts. Probability equals probability of C plus the probability of N minus the probability of C and N. Again, let's put all of our numbers in. We've got C, 0.34 for me. My N is 0.15 minus my chocolate and nuts together, 0.05. Put all three together. Let me do that on my calculator. So I've got 0.34 plus 0.15 minus 0.05. Okay, I'm sorry, that comes out to 0.44. 0.44. So I know that the probability of C, the chocolate or nuts, would be 0.44. And that looks like corn, yeah. C or nuts. 0.44. Find the probability that a cookie does not contain chocolate or nuts. Again, 1 minus 0.44 equals 0.56. So that would be it for that one here. Let's move on to the next one. What are we on now? 19? Okay, good. A college finds that 10% of students have taken a distance learning class. Now, I would have made up my own letters, but this one already says D equals the event that a student takes a distance learning class. So I'm going to write on my board D equals, and there was 10%, so 0.10. 10% of the students have taken that distance learning class. Okay, 20% of students are part-times. Now we are part-time students. This says E equals the event that student is a part-time student. So I'm going to write E equals, because I have 20%, I'm going to put my part-time students are 20%, the distance learning class, there's 10%. Okay, next clue. Of the part-time students, so of these part-time students, which is the main event, 20% have taken a distance learning class. Okay, so what's the event? Part-time students. And of those part-time students, some of them have taken that distance learning class. How many? Mine said 20%. So I'm going to put 0.20 because it says 20%. All right. So this is what we've got so far. These are the clues that they've given us. Let's see what they're asking of us. The probability of D and E. Probability of D and E. Okay, so we don't know this, but we do know, we know the D given E, right? So let's start with that formula. We have D and E, we don't know. And then we would have the probability of whatever the second one is, which is E. Okay, so let's fill in what we do know. We know this is 0.20 equals, we don't know this. So we'll put that back up there. But we do know the probability of being a part-time student is 0.20. So 0.20. Again, it's a division problem. We need to get this letters all by itself. So we're going to do the opposite of division, which is multiplication on both sides. And then these two can cancel out. And 0.20 times 0.20. I tried to do it in my head, but I got it wrong because I thought it was going to be 0.40, but it's not. 0.20 times 0.20 equals 0.04. So just something to think about. Maybe sometimes just use the calculator just because. Okay, so we know that 0.04 equals D and E is going to be 0.04. So here we go, 0.04. Now find E given D. Find how many part-time students given the distance learning class. All right, let me erase my board. Shucks, I should have left everything else. The D equals 0.20, the E equals 0.10, and the E given D equals 0.20, and we know now D and E equals 0.04. Okay, so find the probability of the part-time students. Say if they had distance learning class, that they would be part-time students. The formula would be written out. Oh, there's a glare over there. Okay, let's try that again over here. Okay, we've got the formula E and D over the probability of whatever the second letter is, and that's D. Okay, so we don't know this. That is not the same as D given E, right? E given D, that is not the exact, that's not the same. So we can't put 0.20 here. But we do know what this is. The E and D, right? Those who are part-time students times the distance, because it's right here, right? The distance learning class. So we got 0.04 over those who took the distance learning class is 0.20. Okay, so this is what we're left with right now. We divide that by this 0.04. Oh, I'm sorry. The D. Wait a second. Let me make sure I've got this right. No. Sorry, I've got that wrong because I wrote that wrong when I put it back. This distance learning class is 0.10. And the part-time students were 20, so I wrote it down. Okay, so this is going to actually be 10. So 0.04 divided by 10. Okay. 0.04 divided by 0.10 equals 0.4. So the probability of E given D would be 0.4. That would be for mine. Okay, so find D or E. Again, that was for this. We've got that. Let me erase this and keep all of those up there. Let's see, probability of D or E equals P given D plus P given E, or not given, sorry, probability of D plus the probability of E minus the probability of D and E. Okay, so we have D is 0.10 plus we have E is 0.20 minus the D and E is 0.04. Okay, so we take all three of these and we will get that, right? So let's see, P, D, or E equals 0.10 plus 0.20. Let's sum that in. 0.10 plus 0.20 minus 0.04 equals 0.26, and that's how we get that. Okay, so I've got 0.26. Are D and E independent? D and E are dependent events because D given E does not equal D. Okay, so D given E does not equal this. And so they are dependent events. Are D and E mutually exclusive? And the answer is the events are not mutually exclusive, because when we look at this one here, D and E, if it was mutually exclusive, it would equal 0. But D and E do not equal 0, so they are not mutually exclusive. Okay. Last one for this video. Oh, no, never mind. We will start this one on another video.